in the morning sessions. Okay, so sorry. Right. So what are we doing yesterday? We are doing some work. What is that? Yes, counters we were designing. Is that correct? Hello. This stupid pigeon also.
Ma'am, we are doing 2-bit counters.
Yeah, we did a 2-bit counter. That's true. But did you do for 3-bit counter? Did you extend for 3-bit counter?
Yes, ma'am. Means
Okay, so
well,
you have done for 3-bit counter, right? So now I wanted to tell one thing. When you move from one state to another state, in a synchronized manner, the clock pulse is deciding the change of state. Is that correct? Yes or not? Right? So now, am I in the meeting? Okay. So now, when the clock pulse is changed, right? So now today I wanted to discuss if a clock pulse is changed, how schematical diagram we can draw so that we can show all the state changes in one go, which we will call that as timing diagram. If you remember, earlier also I have mentioned this word timing diagram. Right, so that time I have not shown because this is the exact time where you can understand like how timing diagram can be analyzed so that different states can be understood. Okay, so now let us consider, if at all we consider a clock pulse. Now I am writing a sequence of clock pulse. Now carefully understand. You guys are there or not?
Yes, ma'am.
Very good. So now if at all I take a sequence of clock pulse, right? So I am taking 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 is not a good number, so I will go for 10. Right. So now 10 clock pulses. Right. So now here I have to analyze if a clock pulse is like this. Level 0, level 1. Is that correct? Can I say this is level 0 and this is level 1? And if at all the movement is from 0 to 1, means 0 to 1 transition, I can say it is positive edge transition or trigger. Correct? Right? That means if the sequence of things or the change of state happens at this level from 0 to 1 movement, okay, I can say that it is a positive edge triggered circuit. Right? If the change of state happens this side from 1 to 0, this becomes negative edge trigger. Now you can ask me a question also. If positive edge transition is going on, negative edge transition is going on, that means the change of state is not taking a lot of time. It is happening very quick. Don't you see that? See, the change of state is happening very impulsively. Can I say this is an impulse? Right? So 0 to 1 transition or 1 to 0 transition, either positive side or negative side, I don't think it takes much time for the change of, not this state, the output changes. By the way, the counter is there. For example, your counter is moving from one state to another state, like from 0, 0 to 0, 1. Right? So this change can happen either descent or descent. Anything. Okay, so it depends upon the type of clock you use. So maybe in your diagram, you might have mentioned this one. This is the clock pulse. Right. So what does it mean? This is a positive clock pulse. That means you remember CP is equal to 1 when you have analyzed the sequential circuits. Is that correct? I mean circuits of flip-flop. You remember that? Why no answer?
Ma'am, your video is lagging your audio.
My video is lagging the audio. What nonsense is
Audio is
happening?
lagging.
I'm like video is 0.5x speed.
Who measured that? Abhijit, you measured?
Yes, ma'am.
How?
Ma'am,
Can I correct it?
voice coming first, then video is behind.
Oh, it's coming first. Seriously, my morning also the same issues were going on. I don't understand this institute anymore. Right.
Ma'am, you can rejoin the meeting if possible.
I will rejoin. No issues. Ma'am. I will rejoin again. Let me see what my luck is. Is it fine? Now? Shweta, is it fine?
Ma'am, please write something, then only it will be.
Oh, I'll write something, otherwise I'll dance something. That will be better. Okay. The change of state is coming from
Yes, ma'am, it is fine.
0 to 0. Okay, done. Oh God, what torture, yeah, torture only you guys are. Not only you, everybody. Okay, doesn't matter. Right. What is that I'm telling? Yes. So, if the change of state is happening at this level, that means this transition, level 0 to level 1. Okay. Otherwise, it can happen from level 1 to level 0. Doesn't matter. Right. The change of state should come. But there is a probability at this flat level also the change of state can happen. Don't you agree? Flat level. That means once it
Yes,
reaches
ma'am.
high, in the flat level also the change can happen, but it is very rarely used. Right, very rarely used. Normally edge triggering is preferred, and most of the timing circuits are not only timing circuits, the flip-flops are also manufactured for edge triggering. So that time consistency is there. Like we have at a reduced time, we get the outputs very quickly. That is one of the main reasons. So as of now, remember this one. Right. So in your sequence, right? In your sequence, if at all you have drawn a a 3-bit counter, right? Maybe if at all I should say you have used Q1, Q2, Q3. Okay, I will be drawing this side. Q1, Q2, Q3. Okay, so it is going from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1. Correct? So these are the state and back to this. This is how you have designed, and I think you used T flip-flop. Right. So now the same sequence you can show in a diagram manner also, considering a positive edge trigger, that means this level. So I am pointing out. So for every clock pulse, my criteria is this. At this point only, the change of state will happen. Sorry. For every pulse. Now 10 pulses I have taken. This is the clock pulse. Right. So with respect to the clock pulse, now you see. Okay, I will use a different sketch. Better. So my positive edges all are marked. Right. So that I can have an understanding at this level only my change of state will happen. This is called timing diagram schematic waveforms. Okay. Now, if you see here, Q1, Q2, Q3. Can you just tell me which one is taking the MSB for you? Q1 is taking the MSB. Like that only you have taken? For this level, for this particular truth table or the sequence, Q1 is the highest, then Q2, then Q3. But all the three are following the clock pulse in the positive edge. Is that correct? Right. So now, Q1. I will start with Q1. So only concentrate on the Q1. Q1 is remaining 0 first. So that means I will start with 0 level. This is level 0. Okay, I don't have any reference, so I can start this. Then also it remains 0 in the next. That means from this point till the next level where it has to trigger, it remains 0. Correct? Then again another 0, third 0. From here to here, 0. Then again 0. Then it changed to 1. Carefully understand. It started with 0 at this transition, right? Till the next, this type of transition, it maintained 0. because there also again it maintains 0. From there I am checking out. Again it maintains 0 till this level. So I am taking this blue line as the reference because I have already taken positive edge triggering. Is that clear till that one? And now did you see why a 1 has come here? Because after 4 levels continuous 0, then a change has come, and that too at this edge only. Is that correct? Everybody
Ma'am,
understood?
change should come at the fifth clock pulse now.
No. I have started prior itself. Prior itself. This 0 is also counted for me because clock pulse is a continuous sequence. Right. I have started from here itself. 0 has come from somewhere. That's all. Doesn't matter. It should come at the fifth clock pulse with respect to what you are telling, because my first clock pulse is taken here as the reference. I have a 0th clock pulse also. Doesn't matter. Is your question answered?
Yes, ma'am.
So if a 0th clock pulse started, that means I have a 0th clock pulse as the start. So this is there, then first, then second, then third. So this is also counted. What is the big deal? So accordingly, I will do the others also. Now I will follow that also. Don't worry. Right? Maximum you have a shift. That's all. Is it fine? Is that fine or not?
Yes, ma'am.
Okay. So now, fifth. Then afterwards, it continued. Next till it level next. Also, it is 1. Right. Next level till another 1 has come. So it continued till 4 levels. 1, 2, 3, 4 levels. It continued. Just see, but you can have a mark. I am crossing till here 1 level. Then from here to here it continued. From here to here it continued. Again it continued here. See, you need not show with the beads. You can just draw a continuous line. It should be your understanding. Okay, is that fine? Right. Then afterwards, again back to 0. So at this level, it will be back to 0. Right? So again, it will continue like this. Take it like that. So now 0, 0 and then continues go on. Okay. So this is what Q1 is supposed to be. Right. So this is a waveform indication with respect to the positive edge trigger. Right. Now let us consider Q2. So Q2 already. Now my reference is array 0th pulse only. I started already with 0. Right. So then afterwards, blue line is our indication. Okay. Then continuous force. Q2 is continuous 2. 2 zeros. Then afterwards, 2 ones. I think. Then there is a drop of 0. 0. Then there is 1. 1. 0. And goes on. Is that okay? Q2. Understood? Take Q3 also. Q3. There is a 0, 0th pulse. Then afterwards, first pulse. Then again, there is a 0. Then again, there is a 1. Then again, there is a 0. Then again, there is a 1. Again, there is a 0. Again, there is a 1. And then there is a 0. And then goes on. Is that fine, Q3? Right? So now, if you can carefully understand, first, this one is my start, which I consider that as a part of my waveform. Okay, doesn't matter. So many books shows as a start also part of the waveform. Some books shows after start as the part. Doesn't matter at all. Now, if you check carefully, my Q1, Q2, Q3, first state, Q1, Q2, Q3, 0, 0, 0 has come. In the second one, 0, 0, 1 has come. Then 0, 1, 0 has come. 0, 1, 1 has come. Then 1, 0, 0. Then 1, 0, 1. 1, 1, 0. 1, 1, 1. Then 0, 0, 0 and goes on. Like anyway, this is just a repetition. If you want to show otherwise. Right. Now, this is called timing diagram representation, where we can analyze like this with respect to the clock pulse, a waveform view. Right. And again, if at all you check, there is a lot of applications. Now, consider, don't you think I have generated different types of waveforms? Q1 can act as a waveform triggering waveform to one circuit. Q2 can act for something else. Q3 can act for something else. Don't you feel like another thing? So these lines are disjoint. Please try to understand. It's a continuous line. Okay. Right? Now, carefully understand. According to this positive edge triggering, I can generate 3 different types of waveforms whose duty cycle, like your language of analog electronics, whose duty cycle is completely different, and they can serve as the what? They can serve as inputs to other circuits. Yes. So this is some of the applications I am telling. So now, if at all you can see Q1, Q2, Q3 states can be easily observed with respect to your change of clock pulse. Is that correct? Yes or not? Is that clear?
Yes, ma'am.
The same thing you can work out on your own for a negative edge also. For a negative edge. And now, what can be its waveform look like? With a negative edge. Will it be the same or it will be different? What do you feel? So give your analysis. I mean, torturing to the level of even the nature is also giving torture to me. Pigeons. Tell me. Sorry. What? How the negative edge will be? Will it be the same or it will be different? Negative edge, how it looks like. See, negative edges means what? Yeah.
It looks like same but shifted. Means
See, question comes shifted. With respect to the clock pulse, it is shifted. Right. If I take that as 3 different waveforms, differently it looks different. If with respect to the clock pulse, if I see together, then it seems to be same but shifted. Because we have done this, that's why we can compare it and then take. Correct? So, positive clock pulse or negative clock pulse, we can generate this states. That is first thing you have to understand. And moreover, please try to understand the trick also, how the states exactly do that. Okay, so it is shifted. Point exactly noted. Right. So it looks shifted with respect to the reference. Clear? This is what a timing diagram is. Now, you can absolutely extend the same idea when you have done the flip-flops also. With the timing diagram, you can show the outputs. Right. I was just waiting for this timer circuit that time to explain. Oh, so many times are coming. Okay. So this timer diagram, you can understand here and you can apply the same when you are doing the analysis also. Anything else in this? In this particular topic? Anything?
yes, ma'am.
No problem. Regarding yes, go ahead. Yes.
Ma'am,
Yeah.
in counters, how are we counting? Means how can we count? I understood the process, but how are we counting?
Okay. So now I'll ask you another way. Counters are actually instances. Counters are instances to be frank. Now, for example, not example, I will just take the LED display. Okay. LED display is there. Okay. You have like this. Correct? On this board. Right? Now, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 can be observed here. With a perfect decoder. Hello? Who has asked the
Yes, ma'am.
question? Yeah. So you know the 7-segment display, you remember that? This one, you can display the numbers there.
Yes, ma'am.
Right. So if you display the numbers one after another, how it is going in a sequence? Because we are exactly applying that to a decoder and then changing manually the values. So it is getting displayed. Is that correct?
Yes, ma'am.
Correct. So manually we have a link with the observation view. Numbers are coming and I can assess that. Okay, 0 is there, 1 is there, 2 is there, 3, next 4 should come, 5, 6, 7, 8, 9. Correct? A single 7-segment display. Correct? No? Right? Now, here counter. Why I use the word counter? With respect to the clock pulse. Right? Now, this particular state, which are supposed to be three different signals, right, are combined together, and then they are, let us consider this particular 1, 2 and 3 are connected to three circuit boards. This is circuit 1, this is circuit 2, this is circuit 3. Okay, these are three circuits. So these all are coming from Q1, Q2 and Q3. This is Q1 is controlling, Q2 is controlling, Q3 is controlling. Right. At the stroke of every pulse, this is generated. Is that correct? Then only these three circuits are activated or deactivated according to these inputs. Is that correct?
Yes, ma'am.
Right.
Yes,
So
ma'am.
now, at the stroke of every clock pulse, a changes can be observed in 1, 2 and 3. Is that correct? Right. So the count of the clock pulse, count means the movement or the change of the clock pulse from one instant to next instant is giving a what changeover in these circuits. That means their working style is modified or controlled by this clock pulses movement, which is very continuous. Do you find any gap there? The counter word has come from that. A counting sequence. Did I miss any pulses in that? It's a train of pulses, and the train of pulses is exactly programmed, or I should say exactly circuited. Okay, it has exactly connected, hardwired to generate this, and through this only the other circuits are working out. So it's a big process. This is the main hero. Generated this many things, and these three things are connecting and controlling these three. So now these three circuits, I don't say Q1, Q2, Q3 are controlling. I will say clock pulse is controlling at every instant. Don't you see it is working as a counter? That's why the word counter has come that. What is counting? Who is counting? Don't think that some counter will be there. Counter means it's not a physical thing existing. It is a sequence going on. Continuous sequence. That's why the word called counter, counting sequence. Is that fine?
Yes, ma'am.
Okay. Now, this is a very regular work because I have a regular movement from 0 to 1, 1 to 2, 2 to 3, 3 to 4 and all. Right. Now, if at all, I don't want some sequences to be counted. Like, for example, I want only odd numbers to be counted. Right. So, a preset of 1 I will start, move to 3, 3 to 5, 5 to 7, then back to 1. Okay. So, my present state is 1. Next, it has to go to 3. Next, it has to go to 5. 5 has to go to 7. 7 has to be back to 1. Okay. So, now, how will be my state table? Present state and next state, I will keep very crystal clear. 0, 0, 1 should be first. Then this is the next. 0, 1, 1. Then this is the next. 1, 0, 1. Then this is the next. 1, 1, 1. Then this is the next. Right. If I use a simple T flip-flop, T1, T2, T3. Right. And then make a synchronous circuit. Okay. So I will get now this T1, T2, T3 filling. Can I get the filling? Be crisp. Quickly. This is 1, 2, 3. I will take Q1, Q2, Q3. Okay. Q1, Q2, T1, T2, T3 here. Quickly. Is it possible? Guys are there?
Yes, ma'am. Yes, ma'am.
Chalo, chalo, quick.
0, 1, 0.
Oh. Hey, I want 1, 0, 1, 0. Like this you are doing. Yes?
Yes.
Oh. Quickly.
1, 1, 0.
1, 1, 0. Why out of 104 people, only one fellow is responding? Come on, I want noise, some noise here. Tell. Next.
0, 0, 1, 0.
0, 1, 0. Good. I'm believing you.
1, 1, 0.
1, 1, 0.
0.
Right? So I have T1, T2, T3 ready. So I have T1 equation ready, T2 equation ready, I mean state equation, T3 state equation is also ready. Now I'll make a circuit. Right? Now I'll make a circuit and draw the timing diagram. Okay, now you see. Right? The states. Will it be continuous like this? Or we will have only our sequences, what we have designed for? What do you see? We will have the designed for whatever sequences we have designed for, then only it will be applicable, right? Is that correct?
Yes, ma'am.
Is that correct? So now what is your inference? That means I can, here counting sequence is not there or what? It is also counting sequence. But in an odd number sequence, this is odd, we understand. We understand. Right? Clock pulse don't understand. If we design a circuit for that particular state over change, it will generate that much only. Right? So since it is done, can you draw the timing diagram of this particular flip-flops? I mean Q1, Q2, Q3 now? And post it immediately. You have time, so much time. Quick.
Ma'am, we have to
Yes,
draw for
can I
Q1,
see the
Q2, and
posting?
Q3
Can I
now.
see the posting? Yes. What happened?
Hello, ma'am.
Yes, Ma'am, please go ahead. Help.
Ma'am, I wasn't able to hear the question, ma'am, because
Okay, you're
can you tell me?
oh, it's fine. I just asked, like, since the sequence is ready, T1, T2, T3 is already ready. This sequence, can we draw the timing diagram of this sequence, like present to next state and all? So how that waveform looks? How that wave for this one? Because I went for 1, 3, 5, 7, 1. That means only odd number sequence I went. Right, I have missed the in between numbers. Then also we can able to generate according to the pulses. Odd sequence. So the states will be like 0, 0, 1. Then comes 0, 1, 1. Then comes accordingly. Like, see, change over states. 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. That means that diagram will look different when compared to the regular sequences. So, what I mean to say is, whatever sequence we design, your waveforms also adapt the same manner. Then also it is also a counting sequence. It's not necessary you should count every time. I can only say in between the state 0, the state 2, the state 4, the state 6 and the state 6, they are unused states. I can only use that comment. Right? Because I have taken a or sequence, the rest of the states are unused for me. Similarly, you can go for an even sequence. Otherwise, forget it. I can have a sequence just like that. 1, 3, then 6, then 4, like that. I can measure any sequence. But your clock pulses, right, will follow that sequence. That's all. That is also called a counter. Counter, it doesn't mean that it follows a continuous sequence, right? These are called counters. But there are exclusive counters where we will say that you will have to count from 0 to 9, 9 to 0. Like means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this type of counters are also there. I will explain that. Can I move to that? Right? Okay. Now, is that over? I'm erasing it. Now, if at all, I am just taking a counter which will count up. Up means in the sense it is following a regular one. In fact, it is a 3-bit up counter. It is called 3-bit up counter. Don't you feel that? Don't you feel it is a 3-bit up counter? Why? Because it is moving from
Yes, ma'am.
0. Yes. Yeah, it is up counter.
Yes, ma'am.
Yeah. So now can we do a down counter? What happened to my this? So can we do a down counter? Like see. Simple. Now up counter is done. I will do with the down counter. That means my present state is there. Next state is there. Q1, Q2, Q3. Next state of Q1, Q2, Q3. I'm again using the T flip-flop because very vividly T flip-flops are used. I will start with down counter. Means starting with high 1 1 1. Next will be 1 1 0. 1 1 0. It will be right. Four, 3, 3, 2, 2. It is 1. It is 0. It is again 2. Now, do you feel it is a down counter? Starting with 7, it goes to 6. 6 next state is 5. 5 next state is 4. 4 next state is 3. 3 next state is 2. 2 next state is 1. 1 next state is 0. 0 next state is 7. It's a down counter, right? So we observe and see, right? Now don't you just try to fill up this. What is there in that? So present state, next state. So Q1, Q2. So accordingly T1, T2, T3 will be there and draw the sequential circuit. How it looks. You have up counter, you have a down counter. Already up counter is done. Right now this is a down counter. Now relate those two circuits. Do you find any difference in that? That's all. I only need that much answer. Once you finish it, because I'm continuously using only the T flip-flops, I don't think you will have much difficult in that. Guys are there or not?
Yes, ma'am.
Yeah, quickly. So the
Yes.
yes. Let's see the differences. Observe the differences. Use the same synchronous clock pulse, that too edge triggered, positive edge triggered. In fact, positive edge only we are doing. Then observe the difference between the two circuits. Do you think you find any difference in the circuit? Yeah, because they made of the arrangement T1, T2, T3 state equations are different, might be different. Okay, but draw the circuit and then place them with each other and then check out. And maybe tomorrow you can give me the class also, morning time. Shweta?
Yes, ma'am.
Morning class is free, na? During lab sessions, anyway, you are not doing anything.
Ma'am, I think maybe S2 people can confirm if tomorrow morning is free or not. Swarup can say.
Who? Which one, no?
Ma'am, someone from S2 is free. Ma'am, S2 section is having free tomorrow morning, so
Who is S2? You are in what, Shweta?
ma'am, I am in S1 section. That's why I am saying that someone from S2 section can come confirm if they are having tomorrow morning free or not.
Who is S2? No one is there? Ahan, Aishwarya.
Ma'am, we have lab tomorrow morning.
What lab you are doing? Sitting there. What lab? Hassan?
Language lab.
Language lab, ma'am.
You don't know language? What language you are speaking? What language is that talking? Huh? Language lab you are taking so seriously? By the way, what you do in that? No, out of curiosity, no offense. Out of curiosity, what you do in that language lab?
Ma'am,
Some
we speak
presentations.
in English only. Interact each other.
You interact with each other. Now what you are doing? You barely interact. You better interact in our classes. And that time your internet is going to be working properly. No? No answers. These fellows are very clever. Okay, let me see my this at least. Saturday I will put a class, I mean extra class. That's better, I guess. I'll see. And Dr. Shweta. Shweta, I'll let you know. Okay, that's much better. So that seriously, I mean next week. Next to next week I will give some off. 3 days off I can give, but I think next week I'll do some extra. You know, nobody posted? What happened?
Ma'am, machines class is there right now.
Oh, right now you have
Machines.
machines class. Okay, go. Okay, go. Right. Chalo. But keep me posted that yes.
Question, ma'am. Here we are taking synchronous, right?
Yeah, I am doing synchronous because I didn't start asynchronous. If at all you know already asynchronous, then I don't know. Like I'm
No.
talking more synchronous. Yeah.
Okay. So we are just showing the Q1 and Q2, Q3 in the as compared to clock
Yes,
pulse, right?
yes. T1, T2, T3 waveforms is fine, but I want to see the circuit for both the T1 for the sequential circuit up and the sequential circuit down. How the circuit appears to you.
Oh, okay.
Is that same looking same or something else? That is not my question. I am not asking about waveform. waveforms. Waveforms anyway now you have mastered already. So waveforms drawing with respect to the reference is very easy right now. Okay, so just I want to see the circuit and what is the analysis in that. Okay, let's see. Okay, you can join other class. Thank you.